Okay, well, I didn't do number one, so I'll just do number three because I happened to like look at that. So number three, we noticed that like the number of divisors of 10n is relative to n. It depends on v2 and v5 only, where vp is periodic valuation. What that is basically the number of powers of a certain prime that a certain number has. So in this case, we know that because we're multiplying, because to get from the n to 10 and we multiply by 2 and 5, we're basically increasing v2 and v5 by 1 each. Because we want to increase the total, what is it called, tau function by a factor of 3, we want adding one prime factor will give us like, it will multiply the vp by, sorry, it'll multiply the number of factors by n plus 1 over n for some integer n. And to get threes out of, as a product of such terms, you want it to be 2 and 3/2. So that's how we get the current. That's why we get the reasoning that we want v2 equal to 1 and v5 equal to 2, or vice versa. So then it's just PIE. How do you do this? Multiples of 20. Multiples of 20, there are 50. Those are 50, there are 20. And of both of them, there are how many? 10, I think. Oh wait, I'm body. Sorry, there are oh, wait, 5. Why did I put an extra 0? Positive integers? Yeah. 28. Oh wait, microphone 28. Wait, yeah, I think it's 28. I'm probably clowning somewhere. Wait, 0 and 1, not 1 and 2. We do that with time. So oh, I have no brain. Yeah. After some arithmetic, I think it turns out to be 28 or something. Okay. How do we do this? Uh, eight I think was some global argument, but like I didn't get to it, so I'll go over 6 because I did it. How do you do that? I think we probably have to. I think we coordinate batch this one, but there probably is a better solution than what I came up with. Huh? Okay. Okay, there's no line here too. So confusing. Okay, let's go. So I think I'll just go through the coordinate bash. Well, I'm gonna let the radius be r. So then my coordinate setup was p equal to 04, q equal to -30, and r is equal to 3, 0. So after that, what is done is we like in terms of r, we can find the coordinates of the center. For this, we use similar triangles, and if we notice the 3, 4, 5 triangle where the vertices of the hypotenuse are q in the center of the circle we want, then we can find that the hypotenuse, which should be horizontal along the x-axis, will be 5r/4. From that, then we can also set up the center. Okay, I'll do the rest. Here I'm W logging that Q is like on the left, so that the center of the circle would be like on the negative x-axis, and well, from that we get the center that is displayed right now. That quantity is negative. That x coordinate is negative, by the way. Next, we have to find the circumcenter of triangle PQR. I recall this from memorization that this is 0,7/8. So yeah. Oh wait, can I remember? I don't know. After that, it's just an equation solve. The equation would be this is the equation we get. So what happened? So what this means is that 49/64 is like one of the legs of the right triangle. So we're basically what we want is that the distance from the center of the small circle to the large circle is equal to 25/8 minus r. 25/8 is the circumradius of the large circle. Sorry, the radius of the large circle. Solving that equation, I believe, gives us something along this line. Yeah. So yeah, that's what I have right now. So another part. Oh wait, my computer is dying. Okay, connection is back. After that, I'll just go over what I did. Or does anyone want me to do something else, like a problem? Actually, you know what? Let me live GeoGebra number 9. Okay, let's go. Okay, let me switch my thing to GeoGebra. What is that? Okay, I'll start here, I guess. Why am I drawing a triangle? So okay, let's draw that. AB equal to 20, BC equal to 18. Don't worry about the lengths. What do you want? Let omega be a circle of non-zero radius centers at B, and let L1 and L2 be tangents to omega through A and C respectively. Okay, let's go do that. Those appear to be arbitrary. Okay, let's draw arbitrary. Okay. And what else do we want? K is the intersection. We'll just call it. We'll just choose an arbitrary intersection. I'll just go with that one. Don't worry about naming. So now we want X on segment KA and Y on segment KC. Okay, I think I will rename it because it's getting confusing. KA and KC and such that XY parallel to BC and XY is also tangent to omega. Parallel to BC? Yeah. In other words, something along this line, something like this. I have no idea what I'm doing. So once we have this, what do we want? The maximum possible length of XY. Oh, you can just take. How to do this problem during the contest would be to just do on it with the special case. So what radius can we choose? Cron. Yeah, cron. Okay. I have no way. Just do it this way. What else are we given? Non-zero radius. Okay. Did it say same side? Okay, those appear to be parallel, but we know that they are not. So now it's just something very short, or it could be something that would be close to 38. Integer lengths. Well, we know that it's got to be less than 38. So if one had to guess, one should guess 37. Okay, let's intersect these. Okay, let's intersect I and J. Oops, that's the wrong one. Okay, that is miles away. Yep, that is miles away, all the way over here. And what is that length? The height is about 100. So this circle, it has unknown radius. Let me see what happens when its radius like something at an edge case. Okay, this is the limiting case. What happens then? This length is somewhat manageable now. The height is 78.46. 18, 20. This height is equal to something, I believe. Okay, let's just compute it this way. How do we end the answer format? Maximum possible length. Okay, let's vary that and see what happens, because oh wait, oops. Let me find where. XD. Okay, when is this the largest? It appears to be largest here, but we know that what happens is when it's somewhere here, we want this long segment instead of the pure horizontal segment displayed. Nope, wrong index. Oh, it has to be 0. Yeah, we want that length to be maximal. Let me see if it ever reaches 37. Oh, we want pixel. Very that now. It appears to be maximal. 36 appears to be the limiting quantity, so it appears to be 35 for some reason. Because when it's 36, it's already limiting where D already hits B, which is like undefined. Hence answer equal to 35. Okay, very rigorous indeed. So in like during the actual contest, like you obviously you can't GeoGebra, but like one should be able to notice that these that the lines are almost parallel, so that like the highlighted line FG is somewhat like similar in length to 2 times BC. And I think this test was rather cancerous, so I didn't really do that many problems myself either. And for most of the problems, I can like tell you how to start, but I don't know how to finish it. So for instance, number 8 was just do some global argument, and cannot do those on Olympiads. Last one, it's binary search, but like it's how many ways you can binary search. The restrictions are probably somewhere along the lines of there's no gap that is sufficiently large. This sufficiently large is probably this number is a power of 2. It depends on like after how many levels of searching, that's how large the gaps are allowed to be. Like the gaps of numbers that you have not chosen yet. So if you think about it, like it's a fixed system of guessing where like for the first guess, you always guess the number in the set. In the second guess, you always guess a number from another set. And the sets obviously increase in size as you go due to the nature of binary search, but to like count them is not very trivial. So and I know like other than like that one, there's almost no NT. So well, if this qualified it as N, well, this is more common than NT, so it's almost no NT. Makes sense seeing as it's November. And I guess I don't have much else to say, but okay. yeah, I guess that's about it because there are only 10 problems and